these are the notes for lesson 1.2, algebraic expressions and models. The first thing I want to look at here is the difference between an expression and an equation. An expression contains variables, operations, and numbers. If you remember, variables are letters that represent numbers. Operations would be addition, subtraction, multiplication, and numbers. On the other side, an equation also contains variables, operations, and numbers, but it also includes an equal sign. So essentially, an equation is an expression with an equal sign, or expressions equal to each other. So again, the difference between an expression and an equation: an expression does not have an equal sign. The other key difference is that an expression can be simplified. We're going to talk about what that looks like in just a minute. Whereas an equation can be solved. So an expression, we're simplifying or combining like terms. In an equation, we are finding a value for a variable. Next thing I want to look at is order of operations. This is something you have probably seen for a very long time now, but is something that we definitely need to review before we get into more complicated concepts in Algebra 2. So if you recall, order of operations, we can use "Please excuse my dear Aunt Sally" as the acronym that we can use to remember order of operations. If you remember, the P represents grouping symbols. So this could include brackets, parentheses, any kind of grouping symbols. And it's important to note that we always do the innermost first. So we may have multiple parentheses or brackets, and we always do the innermost ones first. The E represents exponents or powers. If you look over here on the right, the 5 here is our exponent. And the 2 we call our base. And the exponent simply tells us how many times we are multiplying the base. So in this case, we're going to multiply 2 times 2 times 2 times 2 times 2. That's what our exponent tells us. Continuing on, the M and the D stand for multiplication and division. And it's important to remember that we do these operations from left to right. So if we have multiple multiplication or division operation signs in our expression, we are going to move from left to right to evaluate. And lastly, we have addition and subtraction. Again, we move from left to right to evaluate. Now, in order to combine like terms or simplify, terms must contain the same variable and be to the same power. So if we have 2 different variables, we cannot combine those terms. They have to have the same variable. The other thing to remember is they have to have the same power. And we're going to look at an example of that in just a second. Next, we're going to look at the difference between simplifying and evaluating. This is something that a lot of people get confused. So if simplifying, we are combining like terms. Also, when you are simplifying, there will be variables in your answer. Now, on the other hand, when we evaluate, we get a numerical answer. So a number answer. So our answer could be 5 or -7. So we're going to get a number answer. The last thing I want to look at before we look at our examples is we have an expression here. And there are some key terms that I want to review with you. because we are going to be using them the rest of the year. So again, because this does not contain an equal sign, that makes it an expression. Each of these numbers and variables that we are adding and multiplying, or adding and subtracting together, we call a term. So our first term is negative 3x squared. Our second term is negative 5x. Third term is 3x. And our fourth term, our last term, is 7, positive 7. The next keyword is coefficient. And a coefficient is simply the number that comes in front of the variable. So in this case, the negative 5 comes in front of our x. So negative 5 is what we call our coefficient. For the 3x, our 3 is our coefficient, because again, it's the number in front of the variable. And in our first term, negative 3x squared, negative 3 is going to be our coefficient there. Next keyword is variable. Again, a variable is simply a letter that we use to represent a number. So in this case, our variable is x, so that's the letter that we are using. The last keyword is constant, and a constant is simply a number. So in this case, our constant, it does not contain a variable, it's just a number, so therefore that is 7. Now if we look at this expression, we talked about combining like terms. Notice we have a negative 5x and a 3x. They both have x as the variable. They don't have an exponent, so therefore we can combine those together. The negative 3x squared cannot be combined because it has that exponent. Now we're going to use all these terms that we talked about and look at some examples of each. So number one, we are evaluating the power. So again, evaluate means that we are going to have a number answer. So in part A, we have negative 3 to the 4th power. Now remember, we're taking our base and we're multiplying that 4 different times. So this is going to be negative 3 times negative 3 times negative 3 times negative 3. Again, if you have a calculator, you can just plug this in. It is very, very important that you plug in your parentheses. If they give you parentheses in the problem, you make sure that you need to put those in your calculator as well. So if we multiply this together, if we have 4 negatives, that makes a positive, and 3 multiplied out 4 times is going to be 81. So 81 is our final answer for part A. Now part B should look very similar to you, but notice we don't have the parentheses. So this is telling us that we are multiplying 3 4 times, and we just have a negative out front. So we have 3 times 3 times 3 times 3. Now a negative times all those positives is a negative. So this one is actually negative 81. So again, if you don't use the parentheses, it's going to change your answer. So make sure if they're included that you include them as well. Number 2, again, we are evaluating. So again, we're going to have a number answer. We're using order of operations. Again, we are going to start with parentheses or groupings. So notice we're going to start here with negative 2 plus 5, which is 3. So we have negative 4 plus 2 times 3 squared. The next thing that we are looking for is exponents. We do have an exponent here. Remember, the exponent is applied to whatever's right in front of it, or the base. So this is going to be 3 squared, which is 3 times 3, which is 9. Negative 4 plus 2 times 9. From here, we are doing multiplication and division. Notice we just have multiplication. If we had multiple different products in there, we'd go from left to right. So 2 times 9 is 18. So this is negative 4 plus 18. And then lastly, we do addition and subtraction. So negative 4 plus 18 will give us a positive 14. And that is your final answer. Now notice in number 3, it's asking us to simplify. So that means that our answers are going to contain variables. So for the first one, we're combining like terms. Notice we have an x in both of these, so we're just adding the coefficients. So 7 plus 4 is 11. And again, we still have the x there, so it's 11x. Part B, we have 3x squared plus x minus x squared. Again, remember we can only add things that are alike. So the terms that are alike would be our x squareds. Remember, subtracting is the same as adding the opposite, so this is actually a negative x squared. So we have a 3x squared plus a negative x squared, which is 2x squared. And then we are adding on the x. We cannot combine those because we have an x squared and an x, and they are not like terms. So this is our final answer. Lastly, on part C, notice we have parentheses. We want to get rid of these parentheses. So we're going to use the distributive property. So we have 2 times x, which is 2x, 2 times 1, which is 2. Now this is where it gets a little bit tricky. Again, subtraction is the same as adding the opposite. So this is a negative 3 times what's inside the parentheses. So we are going to add a negative 3x, and a negative 3 and a negative 4 is going to be a positive 12. Then we can combine like terms. We have a 2x and a negative 3x, which gives us negative x. We have a 2 and a 12. 2 plus 12 is 14. So our final answer is negative x plus 14. And our last example says to evaluate. So again, we're going to have a number answer. We have the expression negative 3x squared minus 5x plus 7. And we want to know what that is when x equals negative 2. So wherever we see an x, we're going to plug in negative 2. Now again, whenever you're plugging in values, make sure that you use parentheses. So here we have negative 3, and then in parentheses, negative 2 squared minus 5 times negative 2 plus 7. Again, we need to use order of operations to evaluate this. So we're going to start with parentheses. Notice the parentheses are already simplified. We just have negative 2's. So we're going to move on to exponents. So here we have a negative 2 squared, which gives us a positive 4. I'm going to go ahead and rewrite the rest. The next step, we are doing multiplication and division from left to right. So if we start on the left, negative 3 times a positive 4 is negative 12. Remember, we are adding the opposite. So we have a negative 5 times a negative 2, which is a positive 10. And then we're still adding on 7 here. Then lastly, we're doing addition and subtraction from left to right. So we're going to start with negative 12 plus 10, which is negative 2. We're going to add on 7 to that, and that is going to equal 5. So 5 is our final answer.